Hello, welcome to this Understanding React series. Today, this is episode 5. Let's build React's virtual DOM. So we are not going to have React on this page this time. We are going to write it ourselves. We are going to do myCreateElement to make element descriptions like we saw last video, and myCreateDom to turn them into real DOM. And then the interesting part, every state change hands us a new description. So what are we going to do with the two of them? So we are going to do two things. First, replace the whole thing, and then we are going to compare the old DOM with the new DOM and see what changed, and then just change what has changed, which is like a mini version of what the real React does. So let's start. Let's start with the myCreateElement, and I name it myCreateElement so later we can differentiate very easily with the things we made up with the things already built in. Because if I name it CreateElement, then later on I don't remember if it's a built-in or if it's the one I wrote, etc. So the three little dots is, the first two things we pass to the myCreateElement get assigned these two variable names, and the rest of the parameters get built into an array, get thrown into an array, or I don't know how to call it. Return, we are returning an object. That's why the curly brackets. And type, comma, props. And then the props are passed as an object. So then we need to deconstruct, I don't know how it's called, the three dots inside this object with the props passed in being an object. So this puts everything inside this object we passed in inside this object, but it doesn't put an object inside an object. Did you understand what I meant? I don't know. I had to Google that up many times before. So I think that's it, right? So let's use it immediately. An example, constant L as for element, myCreateElement, and then the type of this element will be a paragraph, a P. It will not take an object as props, and the children is just going to be a string, in this case, hello. Easy enough, right? Console.log our element. Control save. Let me open the console. And there we go. Console.logs out an object, a JavaScript object with children, an array of 1, and the array of 1 has inside hello. Cool, no? Now, oops. These reading objects, let me save again. Here is this clearer way to see an object, curly brackets, and then the first key value pair type P, comma, and then props, like we said, and then props is another object by itself with null, so this is nothing, and then the children is an array. So props, like this here, is an object with children being an array of one thing, because we only passed hello. So here it is. Now, let's console.log something, or JSON.stringify. Yeah, let's try this. So we see it as text, but all ugly. Well, we see the object type P, props, another object with children being an array. But we can pass more parameters to this stringify. EL, comma, null, comma, 2. This is just to make it nicer. So this is the text representation of an object in JSON. So JSON is like a text representation of a JavaScript object. JavaScript object notation. Wow. Super cool. EL cooler. EL2. myCreateElement, and now we are gonna do another paragraph. This time we are gonna bring in props. Class name. Hello world. Let me copy paste this, and we are gonna do EL2. Let's hide the first one. There we go. So now, what's the difference? We passed in an object to this props variable. We passed as a parameter to this function. As a second parameter, we passed in an object with a key value pair, and this key value pair is class name greeting. So our object has a type of paragraph. Props, the key props is an object which has key value pairs. The first key, class name, is greeting, and children has an array with only one thing in it, a string hello world. And this is useful to later on convert this into a real DOM element so we can see it over here on the HTML, but we'll get to that. And of course this class name is like if we were gonna do this, right? P, well, even more so, P dot greeting, boom, class equal greeting, like the class name dot greeting is so it can do this, and then here put the hello world. So this is so we can build this. Super duper, no? Okay, so now an even cooler element. I'm going to name it tree. myCreateElement, and this one is going to be a diff from the get-go. And then no more parameters for the diff. But then the rest of the stuff that will get thrown into an array called children. And here's the fun part, or the cool part. myCreateElement p, null, wow. We could have passed EL right here, no? But we can build it here. So it creates it and returns that object we saw in a JSONify version of it. And then let's do another one. myCreateElement, this time a button. All right. Now, of course, for the fun part, let's look at it. Moment of truth. Control S. Boom. So, what happened? Type div, and then props is an object. And the prop, nope, we did not pass any object as the props, so it skipped it. And then we go directly into the children. And the children is an array. And in the array, we have, this time it's not just a string inside the array. It's a whole, until this comma. So it's a whole new object. The one we built with the P, with type P and props, an object with children, and in the children, an array with the string hello, and then comma, and then another object. So it's a list of objects, or an array with objects inside. And the objects inside correspond to this little blueprint we create here, like the one we created here. So let me uncomment Control S. So this part is the same as this part. Okay, is this simple enough? Is this cool enough? Yes, it is. And this tree, let me erase the paragraph. Oh, actually, I uncommented the wrong one. This was the one we were supposed to. Anyways. Oh no, this stays. No, it was corrected. Let me comment this one. Yes. All right. So this object, this is the cool part. This tree made of plain objects. It's an object with key value pairs, and inside this key we have a list of objects. It's an object, and inside one of the keys has a list, and that list, or an array, sorry, that array has objects inside which are the same with key value pairs, and one of them is a list of objects. Well, that tree made up of plain objects, that's all a virtual DOM is. So on every tutorial, React tutorial are out there, we hear this, the virtual DOM mumbo jumbo. So this is it. This is it. Cool, no? And yeah, so yeah, how cool. Yeah, but now we have to put this in the page. And this is where React gets super fun. Well, it only changes, compares when we build another, compares what changed, and then only builds that part. And then that's the tough part. That's the difficult part. We need to see this over here. All right, so let's get to that. So let's start with the base case, which is a string, not one of these objects at all. First, the simplest option, and the choice of words here is important, the base case, because it will turn into a recursive function, which means it will call itself until the only thing that's left is a string, so it returns the base case. So let's start with the base case. Let's function and this time we're going to create a real DOM object, element, and then if this is the base, if the type of element, what we pass in, has a type, so remember, in the array, in the props, that one that's named children, if we just pass a hello, the element is going to be a string. Later on with that. So if the type of element is string, then do this block of code. And we are going to return, so this jumps out of this function immediately and returns back a document dot create text node, and this is a built-in function. JavaScript element So let's console.log this. Console.log the myCreateDom with a string, which is what and there we go. Let me try saving again, see if we see the hello, because this is a DOM object, right? The one that has text content hello, and we usually grab this Control S. Yes, now we see just the hello. So this is a thing we've seen this many times. Sometimes when I hello, it displays an object thing, and if save many times, sometimes it displays the other part. I don't know how that works. Anyways, so let me delete the paragraphs, the H1s, and this. So now we can place this element, this DOM object, in the document, in the page. So instead of console.logging it out, we are gonna assign it my text node is equal to this, right? So now here is the fun part. Const no document dot get element by ID root, and this is starting to look a lot like React, right? Append child. And what are we appending to the root? And if you recall, the root is this div. We already have an empty div right here, and we can see it here in the body. Is it there somewhere? Yes, here's our empty div. Anyways, so where was I? Append child, and we are appending the node we created, my text node. Control save. There we go, a nice hello on our screen. So this text node is also a DOM node. Elements, now on the body we have our div. Now it has a hello inside. All right, let's keep moving. All right, let's keep going. So now let's work on the first one we did, the one that is an object. Remember when we console.log this object? So this will return false if the type of element is a string, because here the type of the element is obviously a component or an object. So let's go take care of that. Let me again comment this out and then. So if the element is a string, we already saw what happens. We create a text node and then we append it. Then, so now let's create we are going to create an object and we're going to name it DOM. Document dot, just like we did with the text, just like we did right here, document create text node, we are going to document create element. And here it will take a string of what type, like p or div or, but in this case it's one of the properties of our object. So we are going to do element dot type, and then we let me console.log created a element dot type, just to see what's going on over here, and let's return the DOM. But now let's call it with the el, right? So we need to console, where is it? So let's get rid of the creation of my text node, and then let me control cut and paste up here the el. Let me comment out the document. Let me get rid of this console.log. Right? All right. So we created the el. Now let's console.log myCreateDom and then el. Let's pass this element. we created with, now it's an object, not a string. Now we're passing an object in here to run this. Let's Control S, and here it is. This console log printed out created a P because element.type is this P. And then this console.log with the created element returns a created DOM element. Document create element P returns this. Well, this P. It's empty because we have not dealt, still not dealt with the child, with the children. Now let's deal with the case where we do get props passed in. Remember, is the EL2 where we pass this object as props with a class name greetings. So let's deal with this. So let's erase this created. Let's go from here. We create a document element of type element.type. That's all right. Now let's deal with the props and the children. So let's get them out. Before we do that, let me uncomment out. Well, I already did. I uncommented out this, yes. So we can see this object, right? So we can see what the props are, the type. This is an example case, so we can work with. So the const we need to pull out the children and then leave the rest of the props. And this is gonna be equal to element dot props. And then let me console.log props for element dot type, comma, because this is a confusing line for me. Props. These props is now these props. Dot dot dot, because element dot props is this whole key. This is the element is the whole thing, and it's an object with key value pairs. The first one is typed. We already used it over here, element dot type, and then element dot props gets deconstructed, and we pull out the thing named children. Okay, here it is, children, and then dot 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 props. So the rest, leave it how it was. So let's see what that does. Let me bring the create element into here, and then let me hide this console log the yes, and then let's, no, this one is okay, but here I need to change to the number 2. Save, and there we go. So let me props for P, and then props, right? So the object, and in this case the object only has class name and greetings. So that's what we console.log, right? Props for, and then The element type is P. We created EL2 is created an element P. If we had created a div, there we go. Props for this div, and then the class name is, and then we the dots, and then we print the props, which is an object. Here it is. So let's keep going. So let me return this to a paragraph, and then what else? We console log back to our we comment out the creation of the EL. We are on the EL2, and we console log myCreateDom. All right, so we console.log out now the props, and just for good measure, let me just console.log the children. So the props are this, and the children is an array that inside has hello world. All right, beautiful. Let's keep going. So now object.keys props returns the keys of the object props in an array. So now we loop through the array and apply a callback. For that, we use our trustworthy for each loop. And our callback. What are we going to do in our callback? We are going to take this object we created and name create a key value pair. Inside the object, we're going to create a key value pair called name. In this case, it's going to be class name because there is no other. This object.keys props is going to return an array of 1 of class name, and it's equal to props name, which is going to be greeting. So is this simple or super difficult? There we go. I save, and when we call the function, we call it inside the console.log. So we are logging out console.logging out the return values, which is now our element paragraph with the class greeting, and it's still empty because we have not dealt with the children. So let's keep going. So this is where it goes a little bit deep into the rabbit hole, because remember when I mentioned the base case that if it's a string, it just returns this, because here now with the children we are gonna it's gonna get recursive. We are gonna call the myCreateDom on the children. So we already saw children is an array, right? So let's go, let me bring this console.log of children down here, and let's console.log Yeah, the same thing. The children. It's an. I was gonna say the children are this, but now we already know the children is this array. The children of this P is this array. So then let's loop through the array. Children dot for each child, and we can name this whatever we want because our for each takes a callback, and this is the param. We name it however we want. Dom dot append child, just like we did in the base. Dom dot, no, not there. Forget what I said. So dot dom, we are appending to the object we create, to this dom, create element. To this DOM we created with the type we pass in this case a P, we are appending a child, and we are appending whatever calling this function returns for each one thing inside this string. In this case it is a string, so it's gonna return a text node, and it will be the end of that because this recursive will only get called once, because what's inside of an array is a string, right? But next we're gonna deal with the tree, so it will get called now with this and then with this. So you see where we are getting at, right? So there we go. P class greeting hello world, because we appended the child, the text node child, we appended it to the P. So here it is, a hello world. So EL2, and then we can console.log the app. So everything is the same, but now we can document get element by ID root, and then we append the app. Boom. Hello world. So let me get rid of the console.log, this commented out. Let me get rid of this comment out. The tree, let me put it here. And now the app is gonna be the return value of my create app, not with EL2, but with the tree. What do you think will happen? Boom. Wow. Magic, no? So myCreateDom, my function, myCreateDom, it's either gonna render a string or another description. So that's the recursive part, because it's gonna append the myCreateDom, and in the case of a tree, the first one, the type div, okay. The props, it's an empty object, okay. But its array, its children, is a list of two things. So then the children, so we then go through each children, and those children are an instruction Again, another object to do this whole thing again with type P, and then this one has its own children. Hello, and then this one which has its own children, click me. So it gets run, then it gets run with the P until it has a hello, then it gets run with the button until it has a click me. So returns this diff, and this is what we are seeing here. Is this deep enough a rabbit hole? It is for me. So I am gonna put it here, children. So let's look at the order of the logs. First the div, then the P, then the button, then the button text. So then it walks back up to the children text. So this is how recursion works. It's kind of funny. So just for funsies, let me just erase the console.logs, right? So we just render this, and this div, where is it rendered? Oh, not console log. We are just displaying it, right? So when we get to the recursive part, children for each child, let's console.log the child. So we're gonna get the arrays. First time the array is an object, this is the child. So the first time around, the child is this object. And then the child is the hello. Then the child is the object, and then the child is the text click me. So just to burst our bubble, what happens if here, instead of this p null and the children being the hello, what happens if our children is a will this break? No? So it works. We passed in another element inside the children of one element. All right, so let me change the type. So the first is a P, and then this is a section. There. So the first element, the first child is this object, and then the second is this object, and then the third is this string, and then this is the next object, and then this is the next. All right, let's move on. So let's get rid of the console.logging. Let's get this back. Let's get rid of all these console.logs. We are moving on. Let's get this back to a hello. And then let's, oops. What? Get rid of this. And then let's get rid of this console.logging. There you go. Right. The create element, the create DOM, and then the tree, create DOM tree is the app, and then we append the app to the root. All right, so now let's do something with the state. So when we change that state, we have to redo the DOM. And the first way we're gonna do it is the simple way. We build again the whole thing. So drop everything, clear everything, and redo it. So let's work on that, the simple version first. So now our little tree is gonna be a div, a null, and my first create element is gonna be a paragraph, hello, but we need the count state. Let count is equal to 0, and create element null comma, and what's gonna be inside, it's gonna be count count, and then the second is gonna be the button, and instead of null we are gonna pass in props. The props are gonna be on click, in increment, we will also add an input, and this will serve as an example in a little bit. Placeholder that's it, no children, just type and props. Yeah. We are gonna do a little to myCreateDom. We are gonna add a counter, DOM nodes created equals 0. We're starting a counter, so every time we run our myCreateDom, DOM nodes created is equal to DOM nodes created plus 1. Yeah. Right. So this, when I save is that we have not written the increment. We do the click. So let's write it. Let's function increment is gonna be count equals count plus 1, and then when we click the increment, that's when the state needs to change. So we need to do a little function here. My update, right? And then we need to run it. We need to create my update. So I will reorganize some stuff. Function my update, and then let me pass the DOM nodes created inside here. And then let's do this. Const container is equal to let's control X. No, it's okay here. DOM not created is not defined because we are calling myCreateElement up here. So let's change this myCreateElement to be a function. Yeah, let's do it like this. Function app function, and on the function app we are gonna return this. Three is not defined. Yes. Const app equals this line. There. Let's experiment. Console.log, and then let's JSON.stringify, and let's call the app. All right, here we go. Let's no, and then 2. So here's what app returns: an object with type and props, and the props has children and then an array with objects 1, 2, and 3 objects: the button, the input, and the P, or the P, the input, and the button. A div with 3 children, and the children are 3 objects. So now let's put this in here. We were doing this in the function update. So we grabbed the ID root and let me comment this, named it container. So then we can we need to clean what's in the container first. Right now it's nothing, but that's why the increment button and the counter and the stuff, right? Append child myCreateDom, and then what this object that my app returns, we call it here. So we append child, we append this of the what myCreateDom returns to the container. And then let's do the console.log DOM nodes created. And then let's use the counter. DOM's node created. But here, yes, here it is. The DOM node created equal to 0. Then we clear everything. Then we append what myCreateDom element returns. The object it returns, the element it returns with these instructions. Control S. What happened? We need to run my update, right? My update. So we run my update to start with. Oops. DOM node created identity is not defined. We are using DOM nodes created identity. I have it upside down. Here we DOM nodes created equals 0, but we have to declare it first outside, no? Where? Let me declare it here. We could even do it like this, no? Yeah, it's the same. We declare it first, so it's like global. Then we assign the 0. Then when we call the myCreateDom, it increments it every time. So here it is. Our counter works, but if I type something, hello everyone, and I click, it redoes everything. So the counter works, but it erases whatever was here. So that was the hope. This whole thing was just to showcase this. The easy way out is we redo the whole thing. We container, set it to nothing, and then redo the whole thing when we update. And we update when we click the increment. If we click the increment, it runs the myUpdate. And myUpdate recreates the whole thing. So does this make any sense? I hope it does. So let me restart this. DOM nodes created. Just to do this, it creates 6 nodes. The div, the p, the p's text, the input, the button and the button's text, right? And if we click this, it creates 6 nodes again. So for performance issues, 6 nodes, rebuild this, that's not the real issue, right? The real issue is this one, where if we type something and change the state, it redoes everything. And here, typing here, it's not changing the state. On the real React, every time we type here, we change the state, because what's in this value, it's also a state. So yeah. So let's start with the juicy stuff. Let's build a function myChanged, and we are comparing A with B. So we're gonna need to change this to only change between one update and another. First, it will check what changed, and if it changed, it will re-render it on the DOM. Does that make sense? So this one gets tricky, but I will just go for it, and then you can review it slowly on your own time, watching the code, because the video is getting a little bit long and it will get longer. Return true. Then if type of A not equal to B, return A dot type all right. So let's do, did it shout? No. Let's do, so 3 rules. Let's do some examples. Console.log myChanged. Oh my, hello. True. This changed. myChanged count equals 0 with count. So these are these 2 different strings. They changed to true. And then what else are we comparing? Let's compare same strings. Hello with hello. False. When it's the same string, it did not change. Now, what else? What 2 things are we comparing now? Let's myCreateElement of a P, comma, null with a myCreateElement with a div. Div, comma, null. And this surely changed because it went from a p to a div, right? Uncut error. This one, comma, this one, index 62. Here. Sorry. I am. Wait, what am I doing? Lol. It's this one that's doing the error, sorry. So yes, AP changed to a div. So it did change. So now on the last one, let's create two. Let's copy this line, copy and put it here. And we already know sorry. We are consoling log the my change of this. The my change of this. And we already know this is true. These two change because it changes from a P to a div. But if we put here a P, false. From this create element with a P and a null to this create element with a P and a null, even though they are two separate objects, for our purposes of if they change, they do not change because they look the same over here, right? So false. So let me like this. Comment out this whole section. So we have the my change function up here, then the whole console logs with it. Let me delete this one. And then the container and the update function. So now let's write the function that it's gonna compare. So I will just go and do this function, which is deeper into the rabbit hole than what we have done so far. Old element, comma, new element, comma, index equal to 0. So it's going to be 4 cases. Case 1, there was nothing here before, there's something now, add it. Case 2, there was something here, now there is not, remove it. Case 3 is there's something in both, but they are different, replace it. And case 4, there's something in both and they're the same, do nothing to it, leave the DOM know how it is, but check the children. So again, it's gonna be recursive. So this is gonna, this function right here is fun. Let's leave it at that. Container dot child nodes index. Old element is equal to undefined let me we will go logging stuff. Container dot append child, and then myCreateDom with the new element. Return right here. No need to go anywhere else. If new element is undefined, then let me console.log remove old element. Return if my changed with old element, comma, new element. So if true, so if they changed, console.log replace, comma, old element. Let me do a little symbol text here. New element. Oh my, container dot replace child create DOM some new syntax, container dot replace child. So if it was a div and now it's something else, we just replace the whole thing because we are not changing something inside of our parent div. Here, our parent div has these three things. So if this changed from the get-go, just replace the whole thing. Right? Now, the fun part is if none of them are undefined and replaced and my changed is false, that means the div is the same, but now we have to go and dig in the children. And this is the whole point of this function. This is the difficultness. All right, you get what I meant. I mean, if new element dot type. Then, so it means true. Console.log same. New element dot type, comma. Now checking its children, right? Righto. Container dot replace child. Sorry. Sorry, it's const old children is equal to old element dot props dot children. Const new children is equal to new element dot props dot children. Const length is equal to math dot max all children length, comma new children dot length. Math dot max between the two lengths. That's gonna be the length. Length of those two arrays, because it's an array, remember? So we loop through an array old school way. Old school. With a for loop. Length I plus plus. And then we run myDiff existing old children new children of I, comma I. So this myDiff is a mouthful. This is something, right? Only this part is something, right? So it's a mouthful. Let's, again, case one. There was nothing here before. There is something now. Add it. Case two. There was something here. Now there isn't. Remove it. Case three. There's something in both, but they're different. Replace it. And then the case number four. There is something in both and they're the same div, for example. So do nothing to it. Leave the DOM node exactly where it is, but check its children in case something deeper changed. So this fourth case is the entire point of the episode. Same means we don't touch it, the real node stays. Its cursor stays. Its scroll position stays. Now we need to rewrite my update. Let current tree equals node. So if there is nothing there, create it. It's one of those cases, right? Don't create it the same. Now we need to const new tree, and this is gonna be what the app returns. Now this is gonna be done for us. The container stuff is gonna be done by our super magical function myDiff. We pass in the container, we pass in the current tree, we pass in the new tree, 0. Then current tree is equal to new tree. Moment of truth. Error. Ring type at my changed. Is it a classic mistake of null not being the same as undefined? Huh. Yes. OMG. Anyways, it's working now. So what happened? So we had current tree equal to undefined, so because it was an empty, so we added. So now if we click here, double nodes created just one. Same div, checking its children. Same p, checking its children. Replace count 0 with count 1. Same input, checking its children. Same button, checking its children. So at the end of the day, just changed one thing. So if we type here, hello again, click me, changes. Again, we are counting 1 to count 2, and this is like it is. So there we go. Our little React thingy, virtual DOM. So yes, this is the whole idea behind the virtual DOM React does, but this is a toy version, so it gets two things wrong. It compares children by position with the same index. Also, it doesn't check the props. So yeah. And this is where the real React, well, the checking the children by the index on the array here. That's why React likes to have a key on each item on a list. We'll look at that later. Anyways, this is already a very long video, so I will wrap it up here. Hope you enjoyed it. Thanks a lot for watching. See you on the next one.